Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kadiruskolo and today I'm with my friend.
My name is Lia Yuliana.
And now the two of us are going to explain our experience regarding the application of data mining with Rapid Miner Studio. We are here today on behalf of our group, which consists of the member me, Muhammad Kadiruskolo, Lia Yuliana, Salatina Sarmento Suarez, Wahidi Hafizan Ahnaf, Zahan Fatihah, and Laila Rizkia. So now let's just get into it. So for the demonstration, the dataset that we have chosen is the dataset of Titanic that is included in this Rapid Miner Studio program. And to do that, we are just going to go to the Turbo Prep and going to load the data. Go to Samples, Data, and Titanic. I'm going to load it. Now as you can see here, we have all of this data in its raw form. It's really dirty. By dirty I mean there's a lot of missing values in cabins, age, and a quick look at the features here. There's a passenger class, name, sex, age, number of siblings, number of parents, ticket number, passenger fare, cabin, port of embarkment, lifeboat, and survive. So first of all, the most obvious thing, lifeboat and cabin. As you can see, there's a lot of reds. This means that for cabin, there's about 77% of data missing, and for lifeboat, there's about 62% of data missing. Now, to deal with this, we have two options. The first one is to just delete all of the missing data. But cabin having 77 missing data means that we are going to delete almost the majority of our data entirely. So to deal with this, we're just going to remove both cabin and lifeboat entirely by going to transform, clicking cabin, clicking remove, apply, lifeboat, remove, apply, confirm. Next, we are left with this set of data. Now I'm going to do something about this number of siblings and number of parents, which I think is quite redundant, as the two of them can be represented by a single column. So next I'm going to create generate. I'm going to drag number of siblings plus number of parents plus 1. The 1 here represents the passenger. So it's going to count number of siblings, number of parents, and the passenger itself. And the name of this column is going to be family size. Update preview, commit generate. So now that we have this column, we no longer need these two, number of siblings and number of parents. So I'm going to delete those, remove. Okay, now we are almost there. So I'm just going to scroll through, and now I can definitely see that in age there's a lot of missing values. To be exact, it's about 20% of them are missing. So compared to the cabin and the lifeboat, only 20% is still manageable. So we can deal with this by completely removing all of the missing values. So to do that, I'm going to click age, and I'm going to click filter. Anything that is not missing, I'm going to apply. So by doing that, we have removed all of the data with missing age value. I'm going to commit. Okay, next up, I'm going to take a look at the passenger fare. So as like a quick visualization, I'm going to go to charts, I'm going to go to I'm going to pick scatter. For the x-axis, I'm going to pick name. The value, I'm going to pick passenger fare. Now, right away, we can definitely see that most of the data are distributed below the 300s. But somehow, there is 1, 2, 3, 4. 4 data that is priced above 500, 512 to be exact. So, these 4 data, we can conclude as being an outlier. This data is an anomaly. So we can remove these 4 data. So to do that, I'm just going to click passenger fare, transform, filter. Anything below 512 is applicable. Apply. Commit. Now I'm just going to take a look again at the same data. And now we have removed the data that is 500, and now our data limit is only reaching 300. So as you can see here, there's a lot of passenger fare with zero values in them. So this can be ruled out also as an anomaly, but I would like to keep in mind that this list may contain some crew members, which technically works in the Titanic. So those data is still quite feasible and not really an anomaly. So next, looking at this features again, we can just take a quick glance at the name and ticket number. So the name and ticket number represent IDs, and I don't think we really need that. So we can remove either one of them. So I'm just going to remove ticket number, as I think we can make do with the representation of name in this data. Ticket number, remove. And also the same thing with port of embarkation. So here's the thing, I don't think port of embarkation actually matters in this data, because what we are going to predict is about survivability, and the fact of the matter is it doesn't matter where our passengers are from. The thing that happens is the ship sank, and I don't think where they're coming from is really one of the most determining factors of where they survive or not. So I'm going to remove this whole column. I'm going to commit. Now that we have this data ready, and we can just do a bit of a small cleanup. Maybe let's say this sex column, we can just transform it, go to rename and rename it into gender to be more formal and less like protruding with the meaning. And I think we are done. So now that we have this data, we can just commit, and then we can go to create process. Now what that does is that we have now established what is the process of our data pre-processing, which is including loading Titanic, unifying column types, and etc., all the way into the end. Now that we have this data ready, we can just export it. Export as CSV. I'm going to name this Titanic pre-processed. Next, and then close. And then after that, we can just go straight into the auto model, and I'm going to import new data from my computer. This is the previous lib files, Titanic pre-processed. Click next, 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 and finish. Now the explanation about the model generation is going to be brought by my friend Leah.
Okay, now we are going to the model explanation or the processing data. Here we can see the data that we already prepared, and the first step is we can do is the predict. Click to predict, and in this predict we can choose what is features that we want to predict. In here we choose the survive as our features to prediction, and go to the next. And this is the prepare target, and this is the amount of the data that is survive, and this is the amount of the data that not survive. Okay, next we can click next, and then this is the select input. In the select input, there is a lot of features in here, as you can see. And in the quality, you can see this is information about the correlation, idealness, stability, missing, and thickness. Same in the right information. So in here, we don't select the name. Why? Because name is ID, so we don't need to select it to the next process. So after that, we can click next. This is the model types. In model types, we choose some of the models that as the constraint of our data. In here, we use the model of naive Bayes, deep learning, and decision tree. So the others, we can do uncheck list. we choose deep learning and decision tree and checklist the others. Okay, after we done, we can click run to run our model, and we should to wait until the data finish the process. This is as you can see, there are overview of the result consists of two constraints. The first is classification error, and the second is runtime. So this is as our constraint to compare which model is more better for our data. Because we use just three models, naive Bayes, deep learning, and decision tree. So in the result, just that models. So we can see in the first constraint is in classification error, the highest model that has highest error is naive Bayes, and the lowest model that has low error is decision tree. And for the next constraint is the runtime. So as you can see, the models that has low runtime or that have high speed of runtime is decision tree, and for the lowest model that has low runtime is the deep learning. So based on the result, so we choose the medium result to know which model is better for our data. So in here we choose the deep learning. Okay, as you can see in the left side in the result, there is a model of each model that we choose. The first is the model from the naive Bayes. We can see the family size, age, and the others features. We can see the model that built by the naive Bayes. And here this is the model from the decision tree. As you can see, there is a lot of branch that identify the every features. And next, this is the deep learning model. This is the describe about the deep learning model. And also, every model have the simulator, so we can change every features to know what is the different result if we change the age maybe or family size and the others. And we can do the optimization, and we can see the change of result. This is the important factor for survive. We can see this is in the y-axis, this is the features of our data. Okay, next, this is also the simulator also in deep learning. We can do the optimize also, and we can see the result after we do the optimize. And this is also same, this is the simulator in decision tree. We do the optimization, and we can see the result after we do the optimization. This is the important factor for survive after we do the simulation. And this is the general information, the statistics of every features, like this is describe the distribution of age. You can see, and this is the distribution of the family size, that who is highest family size. This is the distribution of gender. This is the most is the female, and this is the passenger class, and this is the distribution of passenger fare. This is to know who is the more survived, female or male. And then this is the weight of by correlation. This is the attribute. In the left side is the attribute and the value of weight. And as we can see, the highest rank of weight is the gender. So it means gender have the big impact to the result because they is higher of weight. Okay, that's all from us. The explanation about the expressing the rapid manner using by the Titanic data. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.